up to 8K 14 words. 8K into 14 words of flash program memory, right? One word probably 8-bit right now. 14 words. 8K into 14 words. Flash program memory, you have that much program memory you can use for programming, and then 368 into 8-byte of data memory. RAM. In microcontroller itself, we have a RAM. In our laptop, we have an external RAM right now. In motherboard only, we have RAM. But in a microcontroller, within the microcontroller itself, we have RAM. Mostly these RAM that we are talking about, no, these are function registers, like the registers used for analog to digital conversion, register used for port configuration, register used for timer configurations. All those 368 will be like that only. You won't have a RAM which is maybe there may be some few, but most of them were used as a function registers only. Right now, the 368 into 8-byte, and then 256 into 8 bytes of EEPROM data memory. This EEPROM data memory, no, this is something like a permanent memory. Flash also permanent, EEPROM also permanent. Right. What is the difference? In Flash, you have to do a batch write and batch erase. But EEPROM, you can selectively write memory location, right? And you can selectively erase memory location. Right. That is the advantage. Probably this 256 byte can be used to store DTCs, diagnostic trouble codes, or some sort of system status. Those are permanent. If they come, if the device come to, if the vehicle come to the service center, they can erase it using electrical signal right now. So for that, it can be used. For program itself, we have nearly 8K of 14 words. That is more sufficient for us to write a simple, design a simple embedded system. Even we can develop a cluster, a car meter using that one from my view. Pin out compatible to other 28 pin of 40, 44 pins, PIC16C XX, PIC16F877A microcontroller. That means these microcontroller pins, no, so they will have the same order in these family, 16C family and 16F family. They will have, if they start first pin as VCC, in 16C as well as 16F, first pin will be VCC. Right now. So like that, they have some sort of compatible pin structure between these microcontroller family. That is what they are trying to say here.
Sir, 8K into 14 words means words means in 16 bytes, right, sir?
8K 14 words of 14 words means one word is one instruction, right? If that is the case, 14 words of flash memory means 8K into 14 14 into 14 instructions. 8K into 14 instruction is the maximum flash memory. If that is the case, you have to multiply this 18 into 14, and that much of instruction you can store. Right. So that much of instructions are possible to store. We will explore that, what they are really mean by this 8K into 14 words. When we come to that respective memory architecture, memory map, when we discuss memory map, we will get a clarity on that one.
Okay, sir.
So peripherals. What is mean by peripherals based on our experience? Amir, we have experience before. We discussed about peripherals, memory, ROM, RAM, like that, right now. CPU, ALU, like that. What
Yes.
does mean by peripheral? Can I say peripherals are memory? Peripheral is nothing but a memory in microcontroller. Can I say like that?
Yeah, almost. We will have different peripherals and they're interlinked with any memory part on.
Peripheral is not a memory. Yes, they use memory. Peripheral is a circuitry, logic circuitry.
To the circuit to communicate with the external world.
Yes, we can say X to external world. Yes, it is within a microcontroller. It is a logic circuitry, the logic, digital logic for timer, digital logic for analog to digital conversion. Because these, we cannot do a timer using a memory location. No, there should be some sort of wired circuitry, digital circuitry. Only then we can create a timer. Both of you agree now? Yes or no? Come on. We cannot design a timer using memory. Memory is just a location we can store a data, that's all. I agree. The peripheral is using memory. Peripherals are using RAM to store data and other stuff. But not only they handle the data, but they also process the data to some extent to create some sort of outputs, to digitize something. For those, they have some sort of circuitry. The peripherals in a microcontroller is not a memory, they are circuitry. What circuitry? Digital logic circuitry. Because in the digital electronics, we have a circuitry for timer, we have a circuitry for ADC, we have circuitry for serial communication, we have circuitry for I2C communication, we have circuitry for CAN communication. For everything, we have a digital circuitry. Those circuitries are inbuilt, implemented in the chip itself. We have those things available in the chip. Right. That's why we call them as peripheral features. The peripherals inbuilt in a microcontroller. Totally, in this microcontroller, we have three: timer not, timer 1, timer 2. Right now, timer not is an 8-bit timer counter. So it plays both role. You can use it to you can use it to create a delay. You can also use it to count pulse. And it has a 8-bit prescaler. So I told no, you can scale your input clock using prescaler. Each timer peripherals used to have prescaler. So 8-bit counter, 8-bit prescaler. Timer bot counter, 8-bit prescaler. That is what the timer not in this particular microcontroller. Timer 1. So here the resolution is more. Otherwise, you can count your range of delay that you create now, the amount of delay that you create, right, which is more than timer not. Timer not is an 8-bit timer. It can create only limited delay, but timer 1 can create more delay. Again, it can count more pulses. Timer not can count only 250 pulses, but timer 1 can count 65,565 pulses. The range of counting is more. Again, timer 2 is also an 8-bit timer with 8-bit period register, prescaler and post-scaler. So it has both prescaler as well as post-scaler. Both are there in case of timer 2. Right, but its capacity also limited. it can do only up to 255 pulses it can count. It can create a limited delay.